Welcome to week 4. You've already done a little bit of this. You've already solved system of 2 equations using elimination. Well, now we're going to do substitution. Now, it's still a systematic method, and the first thing we have to have is, you got to remember, we have to have a pair of linear equations in 2 variables. And what we're going to do is we're going to solve for one of the variables, okay? Now, a lot of people say isolate a variable, but in this case, we're solving for one of the variables in either equation. Don't take too much time, but select one of the 2 equations, the one that makes it seem that it might be easier to isolate one of the variables, and use that as your first equation. Once you have, then you want to take that variable once you have isolated it, and you want to substitute into the other equation. When you do that, what you will have now is one equation with one variable. And you can solve for what that variable equals. Now, once solve for variable from up here, you're going to substitute it into that first equation. Whichever one you chose first to isolate, substitute into first used equation. Okay? And at this point, now you can solve for the second variable. Now, once you have solved for both variables, you're not going to want to just say, let's run with those. What you're going to want to do is check that your variables are working. And the way we do that is substitute both variables into each equation to make sure that it's satisfied. And what we mean by that is that once you substitute the variables on the left-hand side, and you do all the math that's required on the left side, it equals what's on the right-hand side. And when you do that, then you know that you have correct variables. So let's look at an example that's up on the board right now, okay? Our example is up on the board. We've seen that last week. It's a rod, a bar, A, B, C, D, that has a pin at A, so it rotates about A, has a bar below it at point B that's, as I rotate in a clockwise direction due to that load at point D, it's going to get compressed, and the member at point C is going to get stretched. Remember, we went through that, and that we isolated it by replacing the reactions at A, and the pin at A and the members at B and C with reactions. And what we got was a B, C, D with 4 unknowns. We then had a free body diagram, and from there, we did summation of moments about point A equal to 0, and you always have to choose a direction. When we did that, we got the equation minus 12 by plus 18 cy equals 720 inch kips. And that was our first equation. All right? Then we did a deflection diagram, right? Last time. And from that diagram, we were able to use similar triangles to get a relationship between delta B over 12 equals delta C over 18 equals delta D, the deflection at the point of the load, over 24. If I isolated the portion of delta B over 12 and delta C over 18, substituted in what I know as the deformation due to the load By and Cy, and rearrange and work with that, I get a compatibility equation, which is relating deflection to load. And that equation was By plus 0.419 Cy equals 23.03 kips. That became equation number 2. So now we are now going to do what this small lesson is all about, and that is solving two linear equations with two variables. And what I want to do is take one of those equations and isolate a variable. What it looks like to me is if I look at equation number 2, by has nothing in front of it, so I don't have to divide through by anything. So the first thing I can do is using equation 2, I can rearrange it, and I get by is equal to negative 0.419 cy. I moved this on the right-hand side, plus 23.03. All right. If I take that now that I've isolated, now I might have had a number in front, I would have to divide through by that number to isolate the variable. What I want to do now is substitute this into equation number 1, once I've isolated the variable. When I do that, equation number 1 becomes negative 12 times negative 0.419 cy plus 23.03 plus 18 cy equals 720. Okay? If I multiply through, I get 5.028 cy minus 276.36 plus 18 cy equals 720. Bring the negative 276 over here by adding 276.36 to both sides, add the two cy's together, and I end up with 23.028 cy equal 996.36. cy then, by dividing through by 23.2028, equals 43.27 kips. Right? If I take this now and substitute this back in, right there into the very first equation we started with, equation number 2, I end up with by equals negative 0.419 times 43.27 plus 23.03 equals 4.9 kips. So now I have what by is equal to. Now I can stop there, but as we said, it's always best to go back and do a check. And so I'm just going to do one of the two. I would like you to do the second one as well to make sure that it works. But as I go back to equation number 1 and substitute in, and here's my check, I get negative 12 times 4.9 plus 18 times 43.27 equals 720. If I do the math, I end up with 720.06 equals 720, which for me says that we satisfied it. Now you might be worried about this 0.06. Well, as it comes back to, I rounded to the hundreds. If I'd have taken this and carried this at the thousandths position, then this number would have been slightly different as well. And I'd take those two, I'd have gotten out many, many decimal points where they're identical. If I substitute them both into equation number 2, I'm going to find a very similar situation. So what we did here is we took two equations, a pair of them. We solved with one. We chose which one. We had two equations, 1 and 2. And we chose number 2 because by didn't have anything in front of it as far as a variable, a number, I should say. And I isolated variable by, substituted back into equation number 1, solved out to get to cy. Now I took cy and put it back into the equation we started all this work with, which was equation 2, and I got 4.9. To check my work, I take what cy and by are and substitute them back into the original equation, and I showed that they are satisfied. Do the second one, substitute them both into equation 2 to show that it's also satisfied, and then don't forget the homework. Remember, you must be completing all these homeworks, and you'll be turning them in as part of your first lessons in freshman engineering. Good luck.